Here we'll get some extra practice on graphing polynomial functions. Our polynomial here is 2 times 3 minus x times x plus 3 squared times x minus 1 to the third power. Our job here is to get our x and y intercepts, and this time we'll also look at the multiplicity of each x-intercept, and we'll get the end behavior as well. Before we go any further, I want to note this 3 minus x term. Note that this is reversed from how we usually write our polynomial terms. We'll usually write the x first and then the constant second. Let's make a slight adjustment to this term to make it consistent with the others. We'll rewrite this as negative x plus 3 inside the parentheses. All we've done is just invert the order in which we write the terms in the parentheses. This is fine because of the commutative property of addition. However, now we can factor out a negative 1 from both terms inside the parentheses. If we factor out that negative 1, all that will do is change the signs of all terms inside the parentheses. Therefore, we can rewrite this as negative 1 times x minus 3, because the negative x changes to x, and the positive 3 changes to negative 3. With this in mind, we can rewrite our polynomial as 2 times negative 1 times x minus 3 times x plus 3 squared times x plus 1 to the third power. Now we'll get the y-intercept. To get the y-intercept, we can replace all of our x's with 0. So everywhere we see x, we'll say 0 instead. Our y-intercept will now be y equals 2 times negative 1 times 0 minus 3 times 0 plus 3 squared times 0 plus 1 to the third power. If we simplify, we'll get a multiplication chain. 2 times negative 1 times negative 3 times 3 to the second power times positive 1 to the third power. Let's first begin by multiplying 2 times negative 1 times negative 3. If we multiply, we'll get positive 6 times 3 to the second power, which is 9, times 1 to the third power, which is 1. 6 times 9 will give us 54. Therefore, our y-intercept will be 0, 54. Using an x of 0, we get a y of 54. Now let's find the x-intercepts. For our x-intercepts, we'll begin by placing each of the terms inside of the parentheses and making them equal 0. Also, be on the lookout for x's outside of parentheses as well. Before any parentheses are written, we have 2 times negative 1. If we multiply that together, we'll just get negative 2. But since there are no x's outside, we will not need to solve for any stray x's. We'll look only inside the parentheses this time. We'll set x minus 3 equal to 0, and x plus 3 equal to 0, and x plus 1 equal to 0. Now let's try to solve for x for each of those pieces. Our first piece will allow us to add 3 to both sides to solve for x. Our second piece, we can subtract 3 from both sides to solve for x. And for the third piece, we can subtract 1 from both sides to solve for x. Therefore, our first piece will give us x equals 3. Our second piece will give us x equals negative 3. Our third piece will give us x equals negative 1. We can also get the multiplicity of each of these x-intercepts by looking to the powers in the polynomial. We may note that x minus 3 has no power written, and if you see no power on the parentheses, this means that it will be first power or multiplicity 1. The second piece, x plus 3, has a 2 as its exponent, which means it will be second power. And the x plus 1 has a third power, therefore we'll make note of that as well. The multiplicity will change the shape of the graph. Any x-intercepts that are first power will appear as a line that crosses straight through on the graph. Any x-intercepts that appear as second power will touch but then bounce off. And then any x-intercepts that appear as third power will do a strange little squiggle shape. We'll also write our x-intercepts in coordinate form. X equals 3 will give us an x-intercept of 3, 0. X equals negative 3 will give us an intercept of negative 3, 0. And x equals negative 1 will give us an intercept of negative 1, 0. Therefore, now we have all of the x-intercepts and we have their multiplicities. Next, let's look to part C, the end behavior. We must first answer if this is an even or odd polynomial. Then we must look to the sign of the leading coefficient. To find whether it's even or odd, we look to the powers above the parentheses and of any x's that are outside of the parentheses. We first note that outside of the parentheses we don't have any x, we just have negative 2. That will not count toward our powers of x. Our first parentheses had a power of 1. We'll even write the invisible 1 in here. When we write that invisible 1, we see x minus 3 is first power. We'll add that to the power of the next parentheses. X plus 3 was second power, and then x plus 1 was third power, and so our total power will be 1 plus 2 plus 3. 1 for the x minus 3, 2 for the x plus 3, and 3 for the x plus 1. Altogether will make sixth power. Because we have a sixth power, that is an even power. And when you have an even power, that means the arrows that represent your end behavior will point the same way. Which way they point depends on the leading coefficient. Be careful about your leading coefficient here. We factored out a negative 1 earlier, and that gave us a leading coefficient of negative 2. Since our leading coefficient was negative 2, we can say the leading coefficient for this polynomial is negative. And if your leading coefficient is negative while you are even, this means both of your end behavior arrows will point downward, not upward. So we can say on the left we go toward negative infinity, and on the right we will also go toward negative infinity. Now, with our end behavior and intercepts in order, we can draw the graph. To begin drawing our graph, let's begin by marking the y-intercept and all the x-intercepts. Our y-intercept is 0, 54 at the top. We'll have intercepts at 3, 0, negative 3, 0, and negative 1, 0. Also, our end behavior says we'll have an arrow pointed down on the left and another arrow pointed down on the right because we should go to negative infinity on either side. To begin drawing, we'll start at the left arrow and we'll go toward negative 3, 0. However, at negative 3, 0, we are second power, therefore we should touch and bounce back off. So we'll draw that line upward. We're going to touch that dot and then come back down. Then we're going to go toward negative 1, 0, the next dot, and for this dot, that's third power. Therefore, we should squiggle through it. So we'll approach negative 1, 0 from slightly toward the left, we'll flatten out, and then continue upward. Then we'll have to go through 0, 54, and then come back down toward 3, 0. At 3, 0, we are first power, and we can just cross straight through. So now we'll pick up that right arrow, and this will be our graph of this polynomial. We're going to make sure that we just touch at negative 3, 0. We'll do the squiggle through negative 1, 0, cross through the y-intercept, and cross through 3, 0. So now we have a completed, albeit slightly messy graph.